Hello, grade 10 students. Welcome to a new chemistry session in Chapter 3 Ions. In this video, we'll cover the following objectives. You need in this session a pen and your chemistry booklet. Let's recall some informations together. An ion could be a cation or an anion. The cation is a positively charged particle. It could be either monoatomic formed of one atom or polyatomic formed of tightly bonded two or more atoms. The anion is a negatively charged particle. It could be also either monoatomic or polyatomic. Let's identify some characteristic properties of ionic compounds. The ionic compound have a crystalline structure. This is the crystalline structure of sodium chloride. The large cohesion in an ionic crystal shows that ionic bond is a strong bond and a high energy is needed to break it. This force of bonding renders the ionic crystal hard and difficult to melt. Consider the following two solutions: sodium chloride solution and aluminum sulfate solution. The ionization or dissociation equation of NaCl is NaCl gives Na plus Cl minus. However, the dissociation equation of aluminum sulfate is Al2SO4 gives 2Al3 plus 3SO4 2 minus. Notice that the ionic compounds dissociate into ions when dissolved in water. The total number of positive charges is equal to the total number of negative charges. Therefore, ionic solutions are electrically neutral. Consider the following setup, made up of a beaker containing distilled water, a lamp, connecting wires, an electric power supply, and two electrodes. Distilled water does not conduct electricity. It is called non-electrolyte. However, when salt is added, the lamp glows. What happens here? When salt is dissolved in water, an ionic solution denoted by Na plus Cl minus is obtained. This solution conducts electricity. It is called electrolyte. Therefore, most ionic compounds are electrolytes. They conduct electricity when dissolved in water. In aqueous solutions, most ions are colorless, such as Na+, K+, Cl-, NO3-. However, some ions have characteristic colors, allowing us to identify them. For example, copper-2 ion has a blue color. However, iron-3 ion have a rusty color. Permanganate ion has a purple color, and dichromate ion have an orange color. Let's determine now the formula mass and the molar mass of some ionic compounds. Given the atomic masses of Na and Cl, let's find the formula mass of NaCl. It is equal to the sum of the atomic masses of Na and Cl, which is equal to 58.5 U. So, the formula mass is the sum of the atomic masses of all atoms present in the formula unit of an ionic compound. Let's find the formula mass of Al2CO3. It is equal to atomic mass of Al plus 3 atomic mass of C plus 9 atomic mass of O, which is equal to 234 U. Given the molar masses of Na and Cl, let's find the molar mass of NaCl. It is equal to the sum of the molar masses of Na and Cl, which is equal to 58.5 grams per mole. So the molar mass of an ionic compound is the mass of a mole of this compound. It is the sum of the molar masses of all the atoms present in the formula unit of an ionic compound. Let's find the molar mass of Al2CO3. It is equal to 2 molar mass of A plus 3 molar mass of C plus 9 molar mass of O. which is equal to 234 grams per mole. Let's observe together. The molar mass of NaCl is 58.5 grams per mole. However, the formula mass of NaCl is 58.5 U. We notice that the molar mass of an ionic compound is equal to the value of the formula mass, and it is expressed in grams per mole. Do you remember that 1 mole of a given ion contains Avogadro's number of ions? By using the ionization equation, we can know the number of moles of ions contained in 1 mole of a given ionic compound. For example, 1 mole of NaCl contains 1 mole of Na plus and 1 mole of Cl minus. However, 1 mole of aluminum sulfate contains 2 moles of aluminum ions and 3 moles of sulfate ions. Let's solve application 1, page 30 in worksheet 10. Consider a sample of 0.1 mole of aluminum sulfate, given the mass number of Al, S, and O, and Avogadro's number is equal to 6.022 times 10 to the power 23 per mole. Calculate the formula mass of aluminum sulfate. The formula mass of aluminum sulfate is equal to the sum of the atomic masses of all the atoms present in aluminum sulfate, which is equal to 342 U. Deduce its molar mass. The molar mass is equal to the value of the formula mass and expressed in grams per mole. So the molar mass of aluminum sulfate is 342 grams per mole. Write the dissociation equation of aluminum sulfate. Al2SO4 3 gives 2Al3 plus 3SO4 2 minus. Determine the number of moles of each ion. 1 mole of aluminum sulfate contains 2 moles Al3 plus. And know the number of moles of Al3 plus present in 0.1 moles of aluminum sulfate. 2 times 0.1 equals 0.2 moles of aluminum ions. Each 1 mole of aluminum sulfate contains 3 moles sulfate ions. So we can know the number of moles of sulfate ions present in 0.1 mole of aluminum sulfate. Then 3 times 0.1 equals 0.3 moles of sulfate ion. Let's deduce now the number of each ion. By applying the formula number of moles of aluminum ions equal to the number of aluminum ions over Avogadro's number, we can calculate the number of aluminum ions. It is equal to 1.2044 times 10 to the power 23 aluminum ions. Also, by applying the formula number of moles of sulfate ion equals to the number of sulfate ions over Avogadro's number, we can calculate the number of sulfate ions. It is equal to 1.8066 times 10 to the power 23 sulfate ions. Let's fill now the concept map, page 32. Matter could be classified either into pure substances or mixtures. The pure substance could be either element or compound. The element could be either metal, metalloid, or non-metal. However, the compounds could be classified into ionic compounds or covalent compounds. However, mixtures could be classified either into homogeneous, colloids, or heterogeneous mixtures. Keep in mind that ionic compounds are formed due to the electrostatic attraction that unites oppositely charged ions. The ionic compounds have a crystalline structure. They dissociate into ions when dissolved in water. Ionic solutions are electrically neutral, where the total number of positive charges is equal to the total number of negative charges. Most ionic compounds are electrolytes. They conduct electricity when molten or dissolved in water. Some ions have characteristic colors in aqueous solutions, allowing us to identify them. Dear students, don't forget to carry out this assignment. Thanks for listening.